Hey everybody, I want to make a video for my regular math students. So far a lot of my videos have been for my algebra class. This is actually going to be the introduction to chapter 7. This is the chapter we would have started if we wouldn't have had our break from school. It is a chapter about congruency and similarity. And before we actually do a lot of stuff with congruent shapes and similar shapes, we had a page in our book which was asking the students, are you ready? Do you have the skills you'll need for this chapter? And so here are some questions that are in that page, or actually I made them up. They're similar to the questions that are on that page. And these first few are actually a review of a 7th grade topic. I haven't taught this at all in 8th grade math, but I'm assuming you've done this in 6th grade or 7th grade. And we'll do a quick review because this is a skill we'll need, especially when we compare similar shapes and try to find the side lengths of similar shapes. We'll need to know how to solve a proportion. Some people call these cross products. Some people call it cross multiplying. There's lots of ways to describe them, but they are all proportions. Now, if you forgot how to do these, the general way that I've done it in the past is you use a calculator to help you when possible. You take the two numbers that are diagonal, you multiply those together, and then you're going to divide it by the number that is diagonal from the variable, right? So for example, if this was my question, I would do 20 times 5. 20 times 5 is 100. If you don't know that, use a calculator. And then once I get 100, I'm going to do 100 divided by my other answer, which over here, 11 times x is 11x. And so what you end up with is 11 times something equals 100. Sometimes it's mental math, but other times it's not. So when it is not a mental math question, that's when you take out your calculator and you do 100 divided by 11. Oops, cleared it out. 100 divided by 11 equals 9.09 repeating bar. Now, obviously, I made these up, so you can see that's why I have kind of some weird answers. Usually, you won't have a repeating decimal as your answer. Some people call this the Band-Aid method, right? See how this looks like Band-Aids that are kind of plopped on there? In other years, I've had students come up from 6th grade and 7th grade and say, oh yeah, we learned this. It's called like the butterfly method or the heart method because they do something like this, where they would do 15 times x, and then down below they would write 15x, and then they would go the other way. They do 18 times 4. You see how that kind of makes a heart, or it makes butterfly wings if I move my phone down. If I drew those longer, it kind of looks like a heart, or it looks like butterfly wings. But you still do the same thing. You're still going to take the two numbers that are diagonal from each other, the 18 and the 4. You're going to multiply those together. 18 times 4 is 72. And then you'll do 72 divided by the other number, the number you haven't used yet. That is the 15. So if I clear out my calculator, and once again, this is going to be another decimal. 72 divided by 15, you get 4.8. So on my question number 2, my answer would be 4.8. Right? So I don't care if you call it cross multiplying, cross products, the Band-Aid method, the heart method, butterfly method. It doesn't matter. As long as you know how to get the answer, a proportion will be a big part of what we do in this chapter. Okay, let me show you a couple examples. What about one more, and then I'll do a word problem, because they can make these look like word problems as well. On my top example, very similar to what we had before. You'll find the two numbers that are diagonal, 9 times 7. If you don't know 9 times 7 in your head, work it out on a calculator. 9 times 7 is 63, and then you do 63 divided by the other number, the number you haven't used yet, in this case 10. So you could do 63 divided by 10. Anytime you divide something by 10, you just move the decimal 1 to the left. 6.3 would be the correct answer right there. Now, obviously, I didn't show my work the best on that example, but I apologize. When they make it a word problem, they're going to try to fool you. Don't let it bother you, right? In this example, a runner goes 3 miles in 19 minutes. At this pace, how long would it take to run 5 miles? Okay. The way that I've had students do this in the past was to make a table. Now, if you don't feel comfortable making a table, that's fine. But in the past, we would make a table. I would always ask the kids, what are we comparing? Well, we're comparing miles and we're comparing minutes, right? And maybe you remember these, they call them ratio tables or ratio boxes, right? And sometimes we would put ratio and actual. We really don't have a ratio here. We just kind of have situation number 1, and then we have situation number 2, right? And so in situation number 1, what I underlined in purple, this person can run 3 miles underneath miles, they can go 3 miles in 19 minutes. So I have 3 miles and 19 minutes in situation number 1. And then what they ask us to find is how long would it take for this person to run 5 miles? So 5 miles goes up here with the miles in situation number 2. We want to know how long would it take this person to go 5 miles, right? So we don't know the amount of minutes it's going to take this person to go 5 miles. Okay? And so in the past, I've had students who are really comfortable doing it like this with a table. If you're thinking you knew how to do it, you could set it up like one of these questions without making a table. That's fine. But in this scenario, a lot of my students in the past say, okay, you're going to do 19 times 5, and 19 times 5 is 95. And then you take that answer, 95, if I get it on camera here, 95 divided by this other number, 3. 95 divided by 3 doesn't go evenly, so you'll use your calculator if you need some assistance, or if you don't have a calculator, just use the calculator on your phone, because everyone's calculator on their phone should work. 95 divided by 3 is 31.6 with the repeating bar minutes. So it'll take this person 31 2/3 minutes to run 5 miles. Right? So if you wanted to transfer that and say that's 31 minutes and 40 seconds, you could be really cool, but most people are okay with 31 minutes, 31.6 with the repeating bar minutes. All right, that is how you'd make a word problem into a proportion. And then there's one other topic in this intro to Chapter 7, and this is actually an 8th grade skill, something we've done earlier in the year. Don't know how rusty we are on it. They may ask you, hey guys, what is the slope between these 2 points on a coordinate plane? Right? And so what you'll have to do is try to graph it on a coordinate plane on graph paper if you have graph paper, and then you'll count how many boxes up, how many boxes over, how many boxes down, and how many boxes over. Luckily, I have this assignment already I grabbed this notebook from school. Oh, apologize about that, knocked my phone over. So like if you look at my first example, I have find the slope between 0, 2 and 3, 2. If you look at my graph right here, 0, 2 and 3, 2. How do you find the slope between these 2 points? Between 0, 2 and 3, 2. We just count the squares, right? To get from the first square to the second square. And remember, you have to start on the left and go to the right. You read a line just like you read a sentence from left to right. So to get from this dot on the left to this dot on the right, I'm going up 1 square, and I'm going over 2. And you can count the actual boxes. That's what the good thing about graph paper is. Up 1 box, over 2, actually over 3. Sorry about that, I missed that third one. Up 1, over 3. And so the slope between these 2 points, remember it's always rise over run, right? I had to rise up 1 box. I ran. I had a run of 3 for going over 3 boxes. And so the slope between those first 2 points would be 1/3. On my second example, between -2, 1 and -1, -1, I believe I made that match up with this example right here, between here and here. Remember, I'm going to go from left to right. So I'm going to start at this dot, and I'm going to go down to this dot. Now, this is obviously a little different than the last one because I'm going down 2, and I'm going over 1. Down 2, over 1. And so whenever I set up my answer for rise over run, I didn't really rise at all, did I? Because I was going down. I went down 2. And so instead of having a rise be a positive number, I need my rise to be negative to represent that I went down. I didn't go up. Positive is whenever we go up. Negative is whenever we're going down. And you should always be going to the right for your the second part of your fraction here. So down 2 over 1 is -2 over 1. Obviously, you can just reduce that as -2. Having something over 1 doesn't really change it. Okay, and then one more example. I have, what's the slope between -1, 5 and 2, 2? -1, 5, and actually I have that wrong. Let me do a quick correction. I don't want -1, 5. I want -1, -5. Let's do that. -1, -5, and 2, 2. And so if you look at my graph A here, you've got this dot right here, which is at -1, -5, and then 2, 2, which is way up here. So they're very far apart, and I actually have some other dots in between them, but we're going to act like we don't even know those dots exist right now. To get from this dot all the way up to this one, right, you can draw a little stick figure here. He's obviously going uphill, so that's a clue this is going to be positive. I'm going up 1, 2, 3, 4, 5, 6. So if I'm going to make my answer over here, I'm rising. I'm going up 6 boxes. And if I want to find my run, how far over am I going? I'm going 1, 2, 3 boxes over to the right. It should always be to the right. If you're not going to the right, you've done something wrong. So I've gone up 6. I've gone over 3. I can reduce that fraction. 6 over 3 is the same thing as 2 over 1, which obviously we can just call 2. All right? So that's how you find the slope when they give you 2 points. It's easy when you have graph paper like I do because you can just count the boxes. If you don't have the graph paper, it's going to make it a little bit tougher, but that is the easiest way that we can do the slope between 2 points without actually doing the slope formula, which I could show you another day if we really needed to. But for now, let's just go with the graph and use that method. So thanks for watching. I'll try to put an assignment, a group of questions, some Are You Ready questions on our McGraw-Hill Math class website if you want to give them a try to see if you're ready to try Chapter 7. And tomorrow we will dive into Chapter 7 a little more. Thank you so much.